Again, welcome to CS332 class, operating system. In these lectures, we're going to discuss about the operating system services. These lectures cover chapter 2, section 1 of our course textbook. So again, here we're going to describe the services an operating system provide to users, processes, and other systems. So let's start with the services. First, here we say that operating system provide an environment for execution of programs and services to programs and users. So again, operating system make it possible for execution of programs to take place in our computer system. As we said in chapter 1, an operating system again control all the computer hardware resources, both the CPU and the memory. These are the two major resources we need in order to execute a program. So one set of operating system services also provide a function that are very helpful to user. And that's what we call the user interface. User interface make it possible for users to interact with the computer hardware. So we have different types of user interface. Example will be the command line, which will be Unix or Linux, and also the graphics user interface, which we call the GUI. A very famous example will be the Windows. Then also we have the batch system also, user interface. So another operating system service is the program execution. As we said earlier, without operating system, a program cannot execute. So operating system, again, operating system doesn't execute the program, but controls the activities. So we can say the operating system controls almost all the activities of all the computer hardware, but the operating system doesn't perform the tasks. Example would be we have a printer. Yes, operating system controls the printer, but operating system doesn't print document or items we need. The printer does the job, but operating system again controls it. So here we say system must be able to load the program into memory and to run that program, able to end the execution. Either it's normally, which is there's no end error successfully, or abnormally, which means there's an error. But the operating system make this possible. Another service is the I/O operations, input-output operations. And again, operating system manage all the input-output devices and operations. So yes, a running program may require I/O, which may involve a file or I/O device. Again, operating system provide the service. Also, operating system provide the file service manipulations. And in order to be able to read from a file or write into a file. Write into a file means we're saving the data into our storage device. Operating system make this work possible also. So a file system is of a particular interest. Programs need to read and write files, directories, be able to create and delete them, also search for files, list the file information, also permission management. All these tasks, again, operating system make it possible. Permission of files will be, example, in our school, we have the registrar office. Staff in the registrar office may see students grading history. Maybe in the accounting department, they may not see that data, or the faculty department, let's say computer science department, may not see the student's financial aid record. So the operating system give the privileges, the permission based on categories. Also, operating system make it possible for communications, either between processes within the same computer or among two or more different computers through networking system. As we know, nowadays our computer system is multi-processing. So we can have 2 or 3 or more tasks being executed at the same time. So operating system will make sure the communication among the process or even the threads are okay. Another task is the error detection. So operating system needs to be constantly aware of possible errors and be able to detect the error possible again, be able to solve the error problems. So this may occur in the CPU. We may have a CPU error, maybe deadlock to processing, trying to get the same thing at the same time, no communication, or memory hardware issues, or IO devices, or the user program, that will be the application software errors. Now, for each type of error, the operating system should take the appropriate action to ensure correct and also consistent computing. Debugging facilities also can greatly enhance the users and programmers' ability to efficiently use the system. Another service is the resources allocation. I would say this is one of the important operating system services. When we have a multi-system, multi-processing, programming software. So for example, if we have 2 threads running at the same time, they must share, both threads may need their own memory, they must share memory, they must share the CPU, processor, who waits first, who goes first, etc. So all this must be done by the operating system. So many types of resources. We may have the CPU cycles. As we said, multi-processing. Not all the processors will get access to the CPU. Some may wait. So we may have a job on the queue. We may have a concept or data structure first in, first out. And maybe there's also a setup for priority queue where we may have a privileges or priority among which jobs must be executed first. Accounting also is very important. Operating system will keep track of which users use how much and what kinds of computer resources. Protection and security services. And the owners of information normally want to make sure their data information system are secured and also protected. So the owners of information stored in a multi-user or network computer system, they want to control the use of that information. Concurrent process should not interfere with each other. We may discuss this in process scheduling. For example, if we have something called a critical position or critical, for example, if we have 2 or more users and they want to access the same data, or they want to update some value from 1 to 2. Now, if you have 2 users and they increment it at the same time, what will be the result? One increment to one want to increment, one want to decrement, and the result will be the same. Most likely, the result will not be consistent. Example like, let's say Amazon database, we have 10 people ordering the same item. Maybe there's only 3 items left. We want to make sure that the first 3 people get it, the rest, the computer system should be able to tell them that no more item is available. But if they all buy it at the same time and the computer accepts all the, because all the others came at the same moment and just accepted all, most likely we may not have a correct, inconsistent information. So protection involves ensuring that all access to system resources is controlled, and also security of a system from outsiders require user authentication. And this also is provided operating system to authenticate the user, both a username and password. So these are all the possible operating system services. We have program execution, I/O operations, file systems, communication, resources allocation, accounting, protection, security, and error detection. Now, next, we're going to go through the user operating system interface. As we mentioned earlier, again, there are three types. The first one is the command line interface, which is based on user may enter a command, and the kernel will again program will execute the command. We have, example will be the Linux or Unix have a multiple flavors, shells. The primarily again, as we say, user may enter the command. So the system fetches the command from the user and then execute it. Sometimes the command can be built in, sometimes just names of programs. So this example of a bunny shell. And this is a command again driven. Then we have the GUI, graphical user interface, Windows, that is the desktop metaphor, where normally we have the icons to move around. Here we don't need to enter any command. Our command is based on, it's event driven. So our command is based on our icon, our keyboard, we can enter the data directly. This concept was invented by Xerox. So many systems now include the command line interface and going together. Example will be the Linux. Previously, Linux is 100% command line interface, but now they have Windows X and kind of, they have their ongoing graphical user interface now. So Microsoft also have going. Also, they have a command line interface, command share. Which is the MS-DOS also. So this example of another interface is mobile devices, touchscreen device. Normally we have the venture keyboard for most mobile devices, smartphones, and again, tablets. So this Mac OS example, which also is a graphical user interface. So that will be the end of our lesson. So our main goal of these lectures is to discuss about the services that again operating system provide, which is again cover our chapter 2, section 1. Section 2, we're going to talk about the system calls. Wish everyone the best. Thank you.